All right, since we ran out of time in class to really go over these last few slides, I figured it would be easier if I just made a little video to kind of sum it up. We weren't going to spend a whole lot of time on them anyway because they don't really go too in depth, and some of it we've covered before. So looking at exponents first, here are the rules for exponents, and we've already looked at a few. At the beginning of last class, the product property, we've looked at this one, a to the m times a to the n equals the same thing as a to the m plus n. We've already done that one. So for example, if I had x to the third times x squared, it would be the same thing as x to the fifth. I would just add the exponents together, because if I have 3 x's being multiplied and they're multiplied by 2 more x's that are being multiplied altogether, I've got 5 x's being multiplied. So this is saying the same thing as x to the fifth. So to simplify that and to write it as one power, you would just keep the base the same and add the exponents. And this is all only if you have the same exact base. Like here we have the same exact base. When we're dividing, since when we multiplied powers that had the same, when we were multiplied powers that had the same base, we added the exponents. When we divide, we subtract them. Okay, so if we had x to the fifth divided by x to the third, that would be the same thing as x to the second. 5 minus 3 is 2. Right? If I have 3 x's on the bottom, that's going to cancel out 3 on the top, so I'm going to be left with 2. So that's why you can just subtract it. Power to a power, we looked at that one. Right? When you're raising a power to another exponent, it's the same thing as keeping the base the same and multiplying your exponents. So if I have x to the third to the fifth, that's the same thing as x to the 15th, right? And then if I have a quotient to a power, meaning I have kind of like a fraction raised to a power, it's kind of like you distribute that power. The numerator is being raised to it and the denominator. So if I have x over y all raised to the power of 2, that's the same thing as saying x squared over y squared, right? Everything on the top gets raised to 2, everything on the bottom gets raised to 2. 0 exponent, we went over that. Anything raised to the power of 0 is 1 unless your base is 0. Negative exponent, a to the negative n, is the same as 1 over a to the n. Okay, so if you have a negative exponent, you take the reciprocal of whatever you have. So for example, if I have x to the negative 2, that's the same thing as 1 over x to the positive 2. By taking the reciprocal, it turns that negative exponent into a positive exponent. And they never want you to leave exponents negative, so you're going to have to know how to do that, how to turn it into a positive. And you just take the reciprocal. All right, so here's another example. Let's say it was 1 over x squared. See the x, or sorry, 1 over x to the negative 2. See the x to the negative 2 was on the bottom. Then you would take the reciprocal of it, so flip it, right? X squared over 1, and that would make the exponent positive. All right, to make it positive, you just basically, if it's over 1, right, or on the top of a fraction, you would flip it down. If it was on the bottom already, you would flip it back up. Okay? And then if you have an entire fraction raised to a negative exponent, you would take the reciprocal of that fraction and it would turn it positive. So if I had x over y raised to the negative 1, that's the same thing as having y over x raised to the positive 1. Okay? So those are the rules and examples of the rules. All right, here's some more, right? 5 to the 7th, so I'm dividing powers that have the same base, so I would subtract their exponents. 5 to the 7th over 5 to the 4th is the same thing as 5 to the 3rd. Same thing here, 2 to the 14th over 2 to the 5th is 2 to the whatever 14 minus 5 is, 9. 3x squared raised to the 4th. So everything in here gets raised to the 4th power. 3 to the 4th, 3 times 3 times 3 times 3. Okay, that's 3 times 3 is 9, 9 times 3 is 27, so 81. Okay, that's what people, if someone makes a mistake, it's always that. They always forget to raise that number to an exponent because they get so concentrated on the variables with the exponents, on the exponent rules. Okay, so 3 to the 4th is 81. X squared to the 4th, remember, power to a power, something with an exponent being raised to another exponent. You multiply the exponents. So that's x to the 8th. Sorry about my handwriting. Okay. 2 over z to the 5th is the same thing as 2 to the 5th over z to the 5th. Right? The whole fraction's raised to the power of 5. That means both the top and the bottom are raised to the power of 5. Same thing here. 2x is being raised to the power of 2, meaning 2 is raised to the power of 2 and x is raised to the power of 2, so that's 4x squared on top. And then everything down here is raised to the power of 2. 3 to the power of 2 is 9. X to the power of 2 is, well, x squared. Y to the 5th to the power of 2, it's a power raised to another power. That's going to be y to the 10th. You're going to multiply those exponents together. And then, ooh, almost forgot. Simplify if possible. 4 9s can't be reduced, but if I have an x squared on top and an x squared on bottom, boop, boop, they cancel out. Right? 4 over 9y to the 10th. 6 to the negative 2, if there's a negative exponent, right? 6 to the negative 2, you can turn anything into a fraction by putting it over 1 if it's not a fraction already. Remember, take the reciprocal. 6 to the negative 2 is the same thing as 1 over 6 to the second. And we can rewrite that as 1 over 36. We can do that. Okay? Same thing here. Be careful on this one. Remember, the exponent only goes with what's directly in front of it. So only the n needs to move to the bottom, right? Because the 2 isn't being raised to the negative 4, the n is. 2 stays where it is. And if I flip the n to the 4th down to the bottom, now it's a positive. And I can't really simplify that anymore. All right, 5 over 8 to the negative 1st. Well, if you have a whole fraction raised to a negative power, just flip the fraction, and all of a sudden it's positive. Positive power, right? And that would just be 8 to the 5th. 8 to the 5th. Or 8 over 5. 8 over 5 raised to the power of 1 is just 8 over 5. There's a your turn on the next slide. So I'm going to flip this. I have the answers on there. Okay, so you might want to pause the video, try it on your own, and then press play again to check your answers. All right, here we go. Press pause if you haven't. All right. So just to go over this real quick. Most of these are pretty self-explanatory. All right. The only one that might have tripped you up is this one here. All right, everything's being raised to the, all this in parentheses is being raised to the power of 2. Everything in here needs to be raised to the power of 2. 3 squared is 9. A to the 5th to the 2nd is a to the 10th. Power to a power, multiplied. AB to the 3rd, that's a power raised to a power. That's the same as AB to the 6th, which then we can go one step further. A times B to the 6th, that means both of these are getting multiplied, or sorry, both of these are getting raised to the power of 6. So that's the same thing as saying A to the 6th times B to the 6th. What's the purpose of doing that? Well, now we can see that we have A to the 10th up here and A to the 6th on the bottom. That can be simplified, right? I have 10 A's up here, 6 A's down here. Hands are starting to shake. So that's going to be, if I have 10 up here and 6 down here, these 6 are going to cancel out, and then I'll have 4 left up here. So 9A to the 4th over B to the 6th, right? That same kind of subtraction rule, A to the 10th, A to the 6th, 10 minus 6 is 4, so the same thing as A to the 4th. Okay, so that's exponents real quick. Okay, and that's as in-depth as we'll go with that. Radicals, we're not going to do much with radicals either. We're going to do a couple of operations with radicals, right? Radical is the name of this, of that square root sign. All right, so here's 3 rules we're going to look at. The square root of A times the square root of B is the same thing as the square root of A times B. So, for example, square root of 3 times the square root of 12 is going to be the same thing as the square root of 3 times 12, which is the square root of 36, which we can do at 6. Okay? So that's the product rule right there. Similarly, quotient rule, if you've got the square root of an A being divided by B, that's the same thing as having the square root of A divided by the square root of B. So for here, that's the same thing as square root of 7 over the square root of 64, and then just simplify anything you can simplify. Square root of 64 we can do, that's 8. Square root of 7 is going to be some ugly decimal, so we're just going to leave it alone. You're allowed to have square roots in the numerator, that's fine. You're not allowed to have it in the denominator, but we're not even going that deep into it. All the ones you'll deal with won't have one, so you'll be fine. Okay? Third rule, adding and subtracting. B times the square root of A plus C times the square root of A is the same thing as B plus C times the square root of A. And same thing for minus. Basically, here's how I think about it. So you know how you can only add like terms? So like if you had 3x plus 4x, it would be 7x, because they're like terms. You can do that. Think of these as like radicals. If you have like radicals, meaning they have the exact same thing under the radical sign, they have the exact same thing in the square root sign, you can just add the numbers that are in front of them, add the coefficients. So for example, if I have 1 square root of 3 here, plus another square root of 3, that's going to give me 2 square roots of 3, or 2 times square root of 3. If I had 4 times the square root of 5, plus 2 times the square root of 5. Those are like radicals. They have the exact same thing under them. So if I have 4 of them, plus 2 of them, that's the same thing as having 6 of them. So 6 times the square root of 5 would be what I'd have there. Okay, same thing with subtraction. So the next 3, the 3 below that, I want you to do. I'm going to release here to show you the answers. Pause the video so you can try them, and then when you have them, come back in. Here we go. That's what you should get. Square root of 5 times square root of 20 is the square root, the same thing as the square root of, oh gosh, hello. Got a mistake. 5 times 20, I added them, look at that. Never too old to make a mistake. 5 times 20 is 100. So that would be 10. Square root of 100 is 10. Whew. Thanks for bearing with me on that. If I was more proud, I'd redo the video, but I don't want to. All right. Square root of 3 over square root of 49. That I can do. That's going to be 7. Square root of 3 is going to be ugly, so I'm going to just leave it alone. Square root of 5, square root of 5, those are like radicals. If I have 4 of them, I subtract 10 of them, I have negative 6 of them. So negative 6 times square root of 5. All right. That's really the last of what we would have covered. All right, so try your best on the homework, and then we will go over it briefly at the start of next class.